Hello guys, welcome to another episode of Dev's Kingdom. This is Jacob. In today's tutorial, we're going to introduce browser use. So you can go to the GitHub page. As in here, so github.com, browser use. Also, you can check out their website. It's browseruse.com. So basically what this project does is to make websites accessible for agents. So if you go to the README, there's a bunch of examples here. Also, they have some videos, but as you can see, it's actually on the browser, so you have to have a desktop to use this product. But in this tutorial, we're going to show you how to build it on Kaggle and run the browser in the backend, so you can actually automate the process. So that being said, let's get started. So first, open a notebook on Kaggle.com, and also this tutorial is on Ollama, so it's open source, so it's free to use. So first, we have to check out which notebook version you're using. If you're using the latest Kaggle version, just do a Python 3.v and which conda you can see if you have conda or not. If you have not, don't have conda, then you have to install it. And that being said, let's continue. So, and then we have to install Ollama. So basically, we have to create a function to run bash command within Python, and the function is called run. And then we'll run this one-line command to install Ollama. After that, we'll just spin out Ollama using Ollama serve. And that's it. So that's basically how we run Ollama. Then we pull the models. So in this demo, we're going to use QWen 2.5 14b. So then we just do Ollama pull, QWen 2.5 14b. And then we check out the Ollama list. You can see we actually installed two models. One's for 7b. The other one is QWen 2.5 14b. So which we're going to use. And then we have to install Chrome. As I mentioned earlier, we're going to do this as a backend browser process. So we're not going to use Windows version or desktop version. So everything is going to be automated. So you can actually first install Chrome and use Chrome as a backend process. So let's continue. Then we have to first do a update for the system. Then we do install this few packages. So lib, indicator, fonts liberation, and also lib vocam1. Basically, we have to install that as dependencies for Chrome. Then we have to basically cd to the Kaggle working folder, then download the Chrome binary as listed here from google.com. Then we have to do the package, install this Debian package, and that's it. So then we can check out the Chrome version, which right now is 131. That's the Chrome version installed for this demo. Also, we can basically do a test. So you have to run Google Chrome stable, run a headless mode. So basically, we do not want this to be on desktop, so you have to run as a backend process. So you have to use headless mode. Disable GPU. We don't need GPU to do that. And then you have to no sandbox. Make sure you test it using a print to PDF. So then, for example, you can use google.com. After you run this command, so basically it will print google.com as a PDF. So after it's actually output to a file, then basically it's going to output to an output PDF. So you can, as you can see here, it's basically output PDF. So you can actually display it. So that's how we display it. So basically we use this library, CPL image, and also use IPython display. So then you can see we just input this as output PDF. You can actually do an embed. So you can do a display the PDF. So you can see this is actually indeed google.com. So this is how you actually test if the Chrome is installed correctly. Then after that, you basically have to install Miniconda. As I mentioned earlier, if you are new version of Kaggle notebook, you have to install Miniconda. So that's the easiest way. Maybe you can use other way to create a virtual environment, but Miniconda is probably the easiest way to build this virtual environment for Python 3.11, which is required by browser use. So browser use needed more or higher version of Python. I think it's more than 3.11 and above. So then you have to basically get this Miniconda package from their Anaconda's official website, then dump it to Miniconda 3, the folder that we created. And then after that, we just run this bash command to run install Miniconda and to this folder, Miniconda 3 folder. And that's it. So then you can also remove this script if you don't need it. After that, we do a conda init. So you can see everything is initiated. then we'll have to create this Python 3.11 kind of virtual environment. So first we create this environment using the Python 3.11 as default Python package. Then we have to install PyTorch or PyTorch CUDA if needed, but this is probably optional. Then we'll have to map the environment from the virtual environment to system environment as we're actually running everything in the notebook. So first we have to remove the default system Python. Then we'll actually do a virtual environment Python to map to the system Python. So as the other mappings, you can just copy everything. I add it here. Also have to map the pip. So basically we have to map the virtual environment pip to the system pip and pip3. So, but that's it. So then you have to add the path. So you have to add the virtual environment bin path to the system path. Also make sure you check the path if they're added. Then we have to basically append also the set packages. So this is for where the pip package installation. So basically everything using pip will be installed in here. So the virtual environment set packages. And then you check the system path. So this is added to the system path. So and then we can check everything is set up correctly by checking all the soft links and also where those binaries are installed. So you can see everything is in the virtual environment. Also, you can check the version of the Python, so on and so forth. So you can see Python is indeed 3.11. So that's how to set up the common environment. If you don't have that in your notebook, then you have to install browser use. So first, clone this repo, clone this offshore repo, and run basically just to cd to this browser use repo, and then do a pip install everything. So I think they use poetry, so that's why you actually have to do a pip install -e everything, so you don't use requirement files. And then let's continue. But before we actually go further, we have to update a few files. So basically, there's one file it's called browser py. So you have to update this if you run everything as a headless mode. So you go to this line, and basically the headless by default is false. So basically, as you can see in the readme of the official GitHub repo, it's gonna open up a browser. But in the notebook, you cannot do that. So you do a headless equal to true, which means everything in the browser will run in the backend. So we also have to disable security. So this is also true by default. So you don't have to change that. But this is the only thing you have to change in this browser file if you don't want to change it again in your script. So you can also do that in the script, but if you update in this way, everything will be default to headless mode. And then you have to update another file to actually do debug if there's an issue with your prompt or LLM. So for service.py, so it's actually in the browser use agent service.py. So the change for this file, you want to actually look at this part. So basically, this is a response from the LLM. You can see this structured LLM. So if there's issue with your prompt or there's issue with the LLM response, then basically they'll error out in here. So if there's an issue there, you can actually put a debug message. So then you can actually see what is the issue. So that's the only thing you have to take a look in this file. And then after that, you have to basically install a few more packages for browser use. So first, if you have an issue with the rich package, you have to do a pip install rich upgrade. And then check out the browser use version. So do a pip list grid browser. You can see the browser version, browser use version is 0.1.19, and that's from the browser use that we actually did a git clone. Then if you want to test Ollama, which we work on demo in this tutorial, so you have to use LangChain because browser use is using LangChain as the LLM sort of like a wrapper or LLM based system. So, and you have to install LangChain Ollama. Also, you can install other LLMs like LangChain Grok or other OpenAIs. But in this demo, we're gonna just use the LangChain Ollama. So install that. Then basically create a file. You call it test Ollama in the Kaggle working folder. Then I'll basically create an agent using this browser use agent. So first the task is go to word.com and return me the title of the website. It's a very simple task. You can try other tasks, but you probably also need to change different models because I think QWen 2.5 14b, sometimes you have some issues. You can change the QWen 2.5 32b or other models. But for that one purpose, we just use the QWen 2.5 14b. Then you can use Ollama from LangChain and then specify the model, which is the QWen 2.5 14b. Then number of contacts with 32,000, and also generate give it to false. And also you can update this in the service file as well. So we just put it into false. And then after that, we just do a wait agent run, and then that's it. So then everything else is actually from the sample readme from here. So I believe that it's very similar to the examples. If you want to try out their examples, they have a lot of examples here. We just select the Ollama example and basically change everything they listed in here. So that's it. Let's go back to Kaggle. So basically after all the files are updated or created, then you have to also install Playwright. So this is how you actually run this automation or run the browser use. So they use Playwright script. So if you install Playwright, just do Playwright install. Then you can see Playwright is also installed in the mini-kernel virtual environment. Then you can just run this file we created, test Ollama, to see if browser use work or not. So just run Python 3, Kaggle working, test Ollama.py. You can see that browser use indeed is working. And basically, it's gonna create different steps. Action 1 is to go to this URL, which is y.com, and then basically did extract the content as an action 2. After that, basically they just did a controller, which is actually taking this into action. So first you will navigate it to the y.com, then extract the page as text. So you can see everything is working. So that being said, this is how you actually run browser use in Kaggle. So as a backend process, not exactly as the official GitHub README, but you can also try the official way. It will actually be able to run that in a desktop environment. So that being said, hopefully this is helpful. If you do like this video, please subscribe, like, or comment. If you have any questions, thank you so much for supporting the channel, and see you in the next one.